Hello, in this video we will cover data types. First we will see single value types, which are integers, floats, strings, booleans and none. And after that we will see collection types, which are lists, dictionaries, tuples and sets. And at the end of the video we will also take a look at print and input functions of Python, which are used to show information on the console or take information from the console. Now let's open a Jupyter notebook and start coding. Integers are whole numbers. Let's see some examples of them. A is equal to 10. 10 is an integer and we have assigned its value to variable a. Now a is holding an integer value. B is equal to 0. 0 is also an integer. And let's say c is equal to minus 5. Integers can have negative values. 10, 0 and minus 5 are all integers and we have assigned their values to variables a, b and c. Now if we call a in here and run this cell, as you see, we can see 10 in here. And also you can change the values of those variables. Let's say a is equal to 7 in here and call a again. You can see that a is changed to 7. So whatever assigned to this variable last is its value. Okay, now let's delete them and run this one more time. Okay, let's take a look at floats. Floats are decimal numbers. Let's see, d is equal to 3.6 and e is equal to minus 20.7. Those are both floats, decimal numbers, and we have assigned their values to variables d and e. Let's call d in here and run the cell. We will see its value 3.6. We can assign d an integer value rather than a float in here, and Python lets us to do this. If I call d for this time and write d and run the cell, as you see, this value is changed to 4 and also its data type is changed from integer to float. Okay, let's delete them and run the cell one more time and start with strings. Strings are basically texts. They are series of characters and they need to be defined in quotes, double or single quotes, it doesn't matter. Let's say f is equal to hello in single quotes and g is equal to world in double quotes. The implementation is different, but the output will be the same. They are both strings. And you can also have a string like this or like this one if you put a blank line in it. As long as you are using quotes, you don't have to write anything in there. You have a string. Let's say I is equal to 10. This is an integer, right? But if you put it in quotes, you will have a string. Strings can have numbers in them. Let's do the same thing with a float with a decimal number 3.4. This is also a string. You can have a string like this with just punctuation. Now let's combine them all and create another string. L is equal to hello world 123 dot 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 and some spaces. This is a string from here to here. We will deeply dive into strings in another section. Now I am passing to casting. With casting, we will convert one data type to another, and we will have three functions: int, float, and str with parentheses. And whatever value we put inside those parentheses, we will convert them to ones that are written in here: int, float, and string. Okay, let's add some new lines in here. D as an integer will be equal to int d. D was a float with 3.6 and this will round it down to 3 and give 3 as an integer to us. Call the integer and as you see we got 3. Okay, let's try I as an integer. I was 10 in as a string and int 10, not 10i. And if I call I integer and run this, we'll get 10 as an integer. Now it converted a string to an integer. Okay, let's write now a as a float. will be equal to float a. What was a? A was 10 as an integer. And if I call a float and run this, we got 10, but this time we have a decimal. Okay, we got it as a float. Let's write j float. This was a string, as you remember, 3.4. And if I put j in the float function and call j float, run this, we got 3.4. Let's add one more line, one more cell in here, and this time use the string function. E as a string will be equal to str e. What was e? Let's check that. It was minus 20.7. Now we will have this as a string. Call estr and run this. As you see, we got minus 3.7, but now we have it as a string. Now let's talk about booleans. Booleans are true or false values, and they only have two options. Let's define m is equal to true and n as false. Okay, booleans are very useful and they have a lot of use cases, and we will see them in the later sections of the course. For now, just know they can only have two values and they are true and false. And this is the end of single value types. Now we are going to get started with collection types, and the first one is lists. Lists are ordered and mutable collection of items. Mutable means changeable. In the later sections, we will see that strings are immutable, lists are mutable, and we will see how those attributes will affect the operations we are making on those data types. Now let's define some lists. We need to use brackets to define a list. Let's say O is equal to brackets. This is an empty list. It has zero items in it. And if you want to add items, you need to add them in an order with commas between them. Let's make this a list of integers. 1, 2, 3, 4, and 5. Okay, this is a list of integers. Let's create a list of strings. Open brackets and write car, ship, and plane. This is a list of strings. You can also have multiple data types in a list. My list is equal to open brackets by 3, hello, 25, and Python. As you see, we have integers and strings in this list. Lists can include other lists. Let's create another one. My other list is equal to open brackets, and I'm going to put those three lists as items in this other list. O, P, and my list are now items of another list. Okay, besides those, we can also add the other data types like integers, strings, and add booleans, floats, and so on. This is how to define lists. Later on the course, we will have a separate section of lists, and we will deeply dive into lists, and we will have a lot of exercises. Now let's get started with tuples. Tuples are ordered but immutable collection of items. They are basically lists that are not changeable. Let's define one tuple. R is equal to, and we need to use normal parentheses to define a tuple. 1, 2, and 3. This is a tuple. Let's create another one with strings in it. Cat, dog, and bird. In the later sections, as I said, we will see lists, and we will see how to change lists, how to add items, remove items to a list, and those will not be applicable for tuples because they are immutable. Okay, dictionaries are unordered and mutable collection of key value pairs, and they are very useful actually. Uh, let's define one. They are defined using curly braces, and we need to use key value pairs in it. Let's think of this dictionary as a data type that holds a person's data, and I will write the first key as name and the first value as John. Okay, Keys and values are separated with colons, and key value pairs are separated with commas, just like the tuples and lists. Okay, let's write age, and this is 32. Job, information, engineer, and a boolean is married will be false. Okay, this is a dictionary that holds a person's data. It has 1, 2, 3, 4 key value pairs, and this is all for dictionaries for now. In later sections, we will have a separate part for dictionaries. Okay, let's get started with sets. Sets are unordered than mutable collection of unique items. This unique part is very important in here. Later we will see a set function that takes a list and removes the duplicate items from it. Okay, let's define one. U is equal to, we will use curly braces again, 1, 2, and 3. Let's create another one with strings. This is also a set, alpha, bravo, and Charlie. Okay, let's call this U in here and run this cell. We see 1, 2, 3. If you try to add one more 3 in here and run the cell, as you see, it didn't accept the last 3 you added. This is the use case of sets. Okay, let's now see the none type. None is a special constant that represents the absence of a value or a null value. Now let's create a variable, define a variable, and assign none to it. Now type is none. Let's run the cell and use this type function. Type function shows the type of the variable you put in those parentheses. Let's call this type and put nothing in it. If I run this, you will see the none type. Okay. Now I'm going to delete this and copy and paste something from here. Okay. I put the variables we have defined before in here to see their types. Let's run the cell, and as you see, A is an integer, float, str, string, boolean, list, tuple, dictionary, set, and none type. Those are the types we have covered. Okay, now I'm going to show you how to use print and input functions to show values on the console or take values from the console. Let's print the variable a, which we have defined before, as 10. If I put a in this print function and run the cell, I'll see its value. You can print text directly. I'll write hello world and run the cell. I will see the text, and you can print anything you want. Actually, I write whatever I want to print and run the cell. I will see the text I have written in here. Okay, now let's see input function. Let's write x is equal to input. You can write an expression in here, enter the value of x. Okay, this function will help us to take values from the console, and after that, using this x, we will print x. Okay, let's run this and see what happens. I'm going to run the cell, and first it didn't print anything. It just showed the expression in input function, and it expects you to enter a value. If I write 12 in here and press enter, then it will take this 12, assign it to x, then print x in here. Okay. At this point, I want to show you something. If you check the type of x and run the cell, you got string. We put 12, this is an integer, but we got a string instead. Why is that? Because this input function always returns a string. So to use x in our program as an integer, we need to cast its type, and we can do it like this: x is equal to int x. And if I check the type one more time, if I run this, I got an integer. But the common use case is like this: take this input function in parentheses and put int for it. So we put it in the int function, and if you run it again, and write 12 again, press enter. Let's delete this one. And if you run this cell one more time after this, you get an integer directly from this input function. Okay, this was all for data types.